Hello there, 8th graders. This is Teacher Krishna, and welcome to our science class for week number 15. And one more time, thank you for entering the online lessons and, of course, for completing all of your assignments. Today, we're going to have very interesting and interactive activities with you, so I'm pretty sure that you're going to enjoy it a lot. So, before we start, just like always, get your book, enter the Google Classroom, download your Word document, and save it in your science folder. And of course, name your document just like it is specified right below. As we move, remember to take notes on the Word document so you can keep track of the most important things from there. Just like always, we have to start with our end in mind, and this week we're going to study lesson number 5, pages 96 to 99. So, and describe the process of heat transfer by summarizing it. This is the first thing you need to keep track on, so make sure you write it down on your Word document. And this week we're going to talk about heat transfer. This is a pretty simple topic to understand, but anyways, it's very interesting to analyze. So first of all, we're going to talk about something extremely delicious and of course one of my favorite foods ever. It's French fries. From the freezer to the table. Basically, you have to heat up oil, submerge it, and then let the heat do its job. So, here we have something very interesting to analyze, which is how heat is being transferred from the oil and from the fire that is heating up the oil to the French fries. And in reality, we actually need some science in order to have extremely delicious and perfect French fries. So basically what happens is that whenever you have a very cold substance and you expose it to a very hot substance, just like the cold French fries and the oil, then the exterior of the material is going to be condensed faster than the one that is inside. And of course, the texture and also the composition will be affected way faster. So, and that is why we need a little bit of science in order to prepare French fries, because of the analysis of all of the heat transfer in it. So, all substances are made of atoms, super little particles, and they are constantly moving. Temperature is the arbitrary amount of energy in motion. How fast particles are moving in an object. So this is very interesting. So absolutely everything is made of atoms. Your computer, your pencil, your bed, absolutely everything. And what is even more interesting is that the particles from all the objects that are around you are constantly moving. But what happens is that when there is a cold object, then the particles are moving slowly. But when there is a very hot object, then particles are going to move very fast, all right? Just like in the example of the French fries. So when the French fries are in the freezer, then all of the potatoes and everything have particles and atoms that are moving very slowly. But when you put them right inside the very hot oil, then the particles start moving faster and faster. And let's continue with heat transfer. And we have several ways in which we can transmit heat. But we're going to analyze thermal energy. So what is thermal energy? It is the total energy in motion in an object. So one more time, remember that particles are moving, and the amount of energy that the particles are producing when they move, that is basically thermal energy. And now we're going to be talking about measuring temperature. It is usually measured with a thermometer, and some thermometers have mercury. And when the temperature rises, it expands. So one of the most typical objects that we can use to measure temperature are thermometers. So And basically, there are some thermometers with mercury, just like it is mentioned, and especially they were used way long in the past. But basically, doctors will have this thermometer at their office, and what they will do is that they will put the thermometer right under your armpit, and they will leave it there from 1 minute to 2 minutes approximately. So after a while, after time passes, then the mercury is going to start expanding because of the temperature that it's being exposed to. And then it is going to reach a certain temperature that will let the doctor know what the temperature of your body is. So regularly, the temperature of our bodies should be around 37 degrees. So if it is above that or below that, it's something abnormal. And we have some temperature scales. And of course, we have to remember that temperature is measured in degrees. But in between this one, we have Celsius, and we have 0 and 100. Why do I have these two numbers? Well, what happens is that water freezes, it becomes ice when it reaches a temperature of 0 Celsius. And at what temperature is it going to evaporate? It evaporates when it reaches 100 Celsius. Now we have another scale, which is Fahrenheit. In Fahrenheit, it is a little bit different. So at what temperature does water freeze according to Fahrenheit? Well, it freezes at 32 degrees. And at what temperature is it going to evaporate water? Well, it's going to evaporate when it reaches 212 degrees. And here we have an example of what an old thermometer will look like. So that reddish thing that you can see right there is basically the mercury that is going to go up or down depending on the temperature that it is being exposed to. Now we have a specific formula to change the degrees from Celsius to Fahrenheit, or from Fahrenheit to Celsius. So basically, the formula in order to change Fahrenheit to Celsius will be Celsius equals Fahrenheit, the degrees that you have, of course, minus 32. Then you're going to divide that by 1.8. Here I have an example for you. Let's suppose that you have a temperature of 189 Fahrenheit, but you don't want to use them in Fahrenheit. You want to use this temperature in Celsius. Okay, so you're going to enter the Fahrenheit degrees inside the formula. So it will be the following. Celsius equals 189 minus 32 divided by 1.8. So the result of the subtraction above will be 157. Then we divide that by 1.8. And the result will be that 87.22 Celsius will be the resultant temperature. So notice that the temperature is basically the same, but the unit is different. For example, if I say 1 meter or 100 centimeters, the distance is basically the same. But in this case, we're talking about Celsius and Fahrenheit. All right, let's continue then. So we have how is heat transferred? So first, we need to define what heat is. Basically, heat is thermal energy that is transferred from a hotter to a colder object. So let's suppose that you have fire, for example, fire in ice cream. So basically, in this case, the hot object will be fire, and the colder one will be the ice cream. So this is basically heat, transferring that hotter energy to a colder energy. And the first way in which heat is transferred is convection. So it's the transfer of heat by the movement of a liquid. So, for example, let's suppose that you have a pan with water in your house. and then you expose it to fire. What is going to start happening to the water? Of course, it will start boiling. But inside the pan, there is something that is a little bit more difficult to observe. So basically what is happening is that hotter water is coming from the bottom to the top of the pan. And cold water or colder water is going from the top to the bottom. So it's like a cycle or a circle that goes on and on. Then we have conduction, and it is the transfer of heat between two objects that are in direct contact. So if you have a cold object in a hot object and they both touch each other, then that is basically conduction. Then we have radiation, the transfer of energy by electromagnetic waves or infrared radiation. So we already studied the waves in some of the last chapters with you. So basically in radiation, you are going to transfer energy, but you are not going to touch the materials. Okay, they are transferred just by electromagnetic waves. And here we have an example of the three we were talking about. Let's start with conduction. So we have a hot object, and of course we have a cold object that will be our hand. So if we touch it, the energy that is in the metal piece that is pretty hot is going to be transferred to our hand. So one more time, when both objects touch each other, that is conduction. All right, so now we have convection, that is what I was telling you about. So look at the water inside the pan. So hot water is going up and cold water is coming down. So the transfer of energy in the fluid is basically convection. And lastly, radiation. So if you put your hand close to this metal piece that is pretty hot, you will notice that your hand will start warming up, even though you are not clearly touching the metal pieces, because it is transferring energy through the electromagnetic waves. All right, now we're going to go with our evaluation. Now please read pages 96 to 99 and summarize it in a Word document. Please read especially page 99. And one more time, I already included most of the information of the topic here, but it's always important that you go by and actually double check all of the content that was included in here. Make sure you include images and of the relevant content. And here is something very important. Create one Word document that contains all of the summaries that you have done so far. You should have 5 summaries in total. So what happens is that every week you were supposed to make one summary, but now I need to check all of the summaries that you have done so far. But you don't have to upload 5 Word documents. You only need to upload one Word document that includes all of the summaries that you have done. Each summary must have, at least 1 or 2 pages long besides images. Remember to include the topic and in mind in each one of the topics, as well as the specifications of the week, your name, grade, and section. And what is the rubric that I'm going to use to evaluate your Word documents? I need order, 1 point, complete content, 1 point, general appearance, 1 point, grammar, 1 point, and images, 1 point. Okay, and besides that, you have to participate in our Zoom session so we can have some interaction with everyone, as well as we can answer any questions that you might have related to the topics. So this is it for today's lesson. Thank you guys one more time for coming. I will be seeing you next week. Goodbye.